Hey guys, I just kind of wanted to cover over a couple of questions on the exam 3 review that I know that will be on the exam. Repeat that I know will be on the exam. So, I hope in doing these questions, you guys kind of like learn something. Okay, well, hopefully not learn, right? But like maybe like refresh things a little bit. So, yeah, I hope you guys, enjoyed the video and learn something. So we're gonna start off with question 3A here. So this is, what is the exact value of? So we have cosine inverse of cosine of 7 pi over 6. So how I like to start off with these questions, right, is look at the parentheses here. So what do we have? We have cosine of 7 pi over 6, right? So if we look at the unit circle, where does 7 pi over 6 land? So if we look at the numerator of here, right, we have 7 pi over 6. So that 7 basically means what? It's bigger than 6, right? So we have a rotation that goes past pi here. Because if we expand pi in terms of pi over 6, right, we can say that pi is equal to 6 pi over 6, right? And what's our angle here? We have 7 pi over 6, right? So basically we can say that it's pi, right? And then we added another pi over 6. So the angle lands somewhere on here, right? So we're asking what's the exact value of 7 pi over 6, right, of cosine. So if we know that, what's the coordinates of pi over 6 in quadrant 1? We have what? Square root 3 over 2, comma, 1/2, right? So our cosine is essentially our x value, and our sine is our y value, right? So if we know that the pi over 6, like the x coordinate here is square root 3 over 2, right? The same can be said here, except what's the signs of quadrant 3, right? We know that the x value is negative, right? And our sine values are also negative. So negative, negative. So if we take the coordinate here, square root 3 over 2, we can say that it's also negative square root 3 over 2 here, and negative 1/2. So if we rewrite this, right, so we know that the value of 7 pi over 6 cosine is negative square root 3 over 2. So this becomes something like that, right? And so when we solve these sort of problems with the inverse, right, we want to rewrite the problem to have a theta, basically. So if I move this out to the outside and bring a theta in, it's gonna look like this. Cosine of theta is equal to negative square root 3 over 2, right? So hopefully this makes it a little clearer. But basically now, since we were dealing with like an inverse, right, we need to remember the domain of like these functions, right? We have cosine, we have sine, we have tan. So what are the domains of cosine, right? Essentially, the domain is from 0 to pi. How we know that is because when we travel from quadrant 1, right? So quadrant 1 is positive, positive, right? Like the x and y values are positive. When we travel to quadrant 2, right? Here, our x values are actually negative because we pass like the y-axis here. So and here it's negative, positive, like that, right? So the domain of pi, or the domain of cosine, is from 0 to pi. So we need to find an angle somewhere between this domain that alludes to the fact that our angle here is negative square root 3 over 2. And so we know that our main angle here is pi over 6, right? So we need to find an angle of pi over 6 that lands in quadrant 2 here. So how we know that is basically our, thing's called the terminal angle, right? So we take pi and we just divide by, or not divide, we subtract pi over 6. So again, like we knew that pi is like the same thing as 6 pi over 6, right? So if we do 6 pi over 6 minus pi over 6, we're left with 5 pi over 6. And that's our guy in quadrant 2. So this guy lands somewhere on here. This is 5 pi over 6. So, and yeah, so our answer here is 5 pi over 6. All right, so here we have problem 4, part B. So it is asking us to find the amplitude, the period, and the phase shift of, so here we have y equals 4 cosine of parentheses 3x minus pi close parentheses. So here I would start off by writing off our model like of cosine. So it'd be like y equals a cosine of bx minus c plus b. So what do these mean, right? So A is our amplitude, B is just our B, C is our phase shift, and D is our vertical shift or our midline, right? So we're asking to find the amplitude, the period, and the phase shift, right? So we start off with the amplitude. So here, if we look to compare the two models, right? We have what? Y equals 4 cosine, and what's here? Y equals a cosine, right? And we know that A is our amplitude, so amplitude in this case is just 4, right? So period. Period's a little more complicated here, right? So we're finding B here. What is our B if you compare, right? Or we have bx minus c over here, and we have 3x minus pi. So our B is equal to 3 here. If we just compare, right? So we get 3, right? So our phase, or our period is a formula to it. So this would be 2 pi over b. And we just found the b is 3, right? So our period in this case is just 2 pi over 3. So, and then how we're trying to find our phase shift, right? So we're trying to find our c. If we look here, right, we have bx minus c, and here we have 3x minus pi, right? So notice that we have a minus and a minus, right? Our phase shift here would be just pi, because it has to match like this, the minus pi here. So here we have problem 4. This is part A. So here we're told to find the amplitude, the period, and the phase shift of. So here we have y equals -1/2 sine of 2x plus pi over 5. So I would start off by writing up like our model equation here. So this is y equals a sine parentheses bx minus parentheses c close parentheses again plus d. So here we're trying to find the amplitude, right? So if you remember, amplitude is just our a here. So if we compare this, right, we have what? A -1/2. So the problem with amplitude is that amplitude can't be negative, because the amplitude is like essentially the height that the graph like touches, right? So imagine like an absolute value here. So our a is just 1/2. Period. So here we're trying to find the b value, right? If we look over here, b is inside the parentheses, bx, right? Here do we have a 2x inside the parentheses. So our b is just 2. But we're not quite done yet, because we're trying to find the period, right? So there's a formula for period. It's 2 pi over b. So we just found b just now, right? So if we plug this b in, right, we have 2 pi over 2, right? So we have a 2 on the top and we have 2 on the bottom. So we just kind of cross those out, and our period equal to pi. So now we're trying to find the phase shift, right? So how do we find the phase shift? Basically now we're trying to find the c. So we should put c equals here. So how do we find phase shift, right? So if we compare the models, right, we have a 2x plus pi over 5, right? And we have a bx minus c. If we were to plug in this pi over 5 into this formula, right, we get a bx minus pi over 5. So the way I like to envision c is that whatever sign is like in front of the c, like so in this case we have a negative pi over 5, I kind of just take this whole thing as our c here. So our c here is equal to just negative pi over 5. So to find phase shift, right, it's yet another formula. So I'm just going to put phase shift is equal to c over b, right? So we just found c and we have b already. So our phase shift is equal to what? Negative pi over 5 all over b, right? And our b is equal to what? 2, right? So we have a fraction over a whole number, right? So in this case, I like to take the denominator here and just kind of multiply him into the denominator of the top fraction, right? So this is multiply. So this becomes negative pi over 10, negative pi over 10, because I multiplied the 2 into the 5 here. So our phase shift here is just negative pi over 10. So another method I can do instead of doing like this like division problem, I can kind of like envision it like it's negative pi over 5 divided by 2 over 1, right? So to get rid of this division problem, right, I'm basically like flipping, I'm getting the reciprocal of the bottom one and multiplying instead now. So this becomes negative pi over 5 times 1/2. So again, so I kind of just like flip this around to make it a multiplication problem. And so now I kind of just multiply across. So this negative pi times 1 is just negative pi, and then 5 times 2 is is 10. So we're left with negative pi over 10 is our phase shift. Okay, so problem 7. So it's asking, find the exact value of these problems, right? So starting with A, we have what? Cosine inverse of 1. So I want to get rid of that inverse, right? So I'm going to rewrite the question as cosine of theta. So essentially, imagine like imaginary theta on this side, right? Like equal to theta. And then I'm going to basically switch the 1 and the theta here around. So like I can get rid of the inverse. So it's cosine theta equal to 1, right? So remember, like a little refresher, right? That when we're dealing with inverses, right? There's domains associated with each respective function, right? So for cosine, right, his inverse falls between 0 and pi. So basically, our positive values of cosine are in quadrant 1, our negative values are in quadrant 2. Sine is negative pi over 2 to pi over 2. So essentially, quadrant 1 or 4, right? So our negative values are down here, our positive values up here. Tan, same gist, right? So we have a negative sign here, so our tan is also negative down here, and then positive tan up here. So back to the question, right? So it's asking, at what angle is cosine equal to 1? So if we look at from 0 to pi, right, where is our positive values? Our positive values lie in quadrant 1, right? So within quadrant 1, what angle gives cosine equal to 1? So if you remember, right, we start here at 0, right? But the actual point of 0 is 1, 0, because our point starts like at the edge of the circle, right? So our radius here is like 1, but ignore that. Like we start at point 1, 0. So our answer here is 0. It's like the angle 0, or because we start at 1, 0. So theta is equal to 0. All right. So our problem here is tan inverse of negative square root of 3, right? So again, like I did before, right? I'm going to change this problem so I don't have an inverse. So this becomes tan of theta is equal to negative square root of 3. So remember that tan is broken down into what? Sine, right? Sine theta over cosine theta equal to negative square root of 3. Right. So I want to change this negative square root of 3 to match like this guy, right? So I'm going to put him over 1. So it's like a fraction is equal to a fraction, right? So remember when we talk about coordinates like of an angle, right? We always match with like it's something over 2 comma something over 2. I'm going to do that same thing here. Now bear with me, right? This might look a little confusing, but so sine theta over cosine theta equals negative square root of 3, and I'm going to put him over 2, right? All over 1 over 2. Make sense? So now, right, I'm looking for an angle that satisfies these criteria, the criteria. So I have tan inverse, right? Remember that like every inverse has its own domain, right? So my domain of tan inverse is what? It's negative pi over 2, comma pi over 2. So basically from negative pi over 2 to pi over 2. So quadrant 1 and 4, right? And what do we have? We have a what? A negative value, right? So basically it's telling us that it's in quadrant 4. So basically now we're asking what angle in quadrant 4 has these coordinates. So remember that our sine value, right, is essentially our y value. So imagine this guy as our y value and cosine is our x value, right? So what angle in quadrant 4 has an x value and a y value, or an x value of 1/2 and a y value of negative square root 3 over 2, right? And basically, if you look at a unit circle or our data values, right, whatever preference you use, it's our angle here is negative pi over 3. Make sense? So basically, our answer here is theta is equal to negative pi over 3. So for question 7e, right, now we have sine inverse of square root 2 over 2. Again, right, so I'm going to get rid of that inverse. So I'm going to write this as sine theta is equal to square root 2 over 2. So now, again with the domain, right, so looking over here, our domain of sine is what? Negative square root 2, negative pi over 2, right, to pi over 2. So basically, again, quadrant 1 and 4, right? So what angle gives us a positive value, a positive sine value, right? Quadrant 1. So what angle in quadrant 1 gives us a y value of square root 2 over 2? And if we look at the unit circle again, right, we know that our theta here is equal to pi over 4. So again, this is question A, right? So this is now question C. So we have sine of cosine inverse of negative 1/3, or negative 1/3, right? So that negative 1/3 doesn't really look like a coordinate from our unit circle, right? So basically now we know this is a triangle question, right? So I'm going to isolate the cosine inverse right now, right? So this is cosine inverse of negative 1/3. So remember the domain again of cosine inverse? It's from 0 to pi, right? So we're looking for a negative 1/3. In what quadrant, right? Quadrant 1 or quadrant 2 do we have a negative cosine value? Quadrant 2, right? So here I'm going to set up my triangle to be in quadrant 2. So our angle is here. This is theta. This is our right angle. And then we have values of 1/3. So again, I want to get rid of that inverse, right? So I'm going to rewrite this problem as cosine of theta is equal to 1 or negative 1/3, right? So if we remember the domain, right, we figured that already, it's in quadrant 2. So now cosine is equal to negative 1/3. So I'm going to write out SOHCAHTOA here. So remember the order, right? SOHCAHTOA. So COT, right? So it's adjacent over hypotenuse. So negative 1/3. So negative 1/3. Adjacent over hypotenuse. So now we're left with sine, right? We want to find the sine of theta here essentially. So sine of theta. But we don't really have our opposite, right? So what does that mean we have to do? Pythagorean theorem, right? So if you remember the formula for Pythagorean theorem, it's a squared plus b squared equals c squared. So we have our a here. Let's call this adjacent as a, right? So we have our negative 1 squared plus b squared because we don't really know what this b is. And our c squared is always our hypotenuse, right? So in this case, it's 3 squared. So negative 1 squared gives us 1 plus b squared equal to 9. We want to isolate the b, right? So this becomes b squared equals 8 because I subtracted 1 from both sides, like that. And left with b squared equal to 8. So I'm going to square both sides here. So this becomes b is equal to square root of 8. So write that in. And again, this is in quadrant 2, right? So our y values here is positive. So our square root of 8 is positive. So our sine of theta here is what? SOHCAHTOA, right? So it's opposite over hypotenuse. So opposite of theta is square root of 8. Square root of 8/3. Okay, so I just noticed that the answer key actually has like a simplified version of this. So it's simplified as radical, right? Imagine like our factors inside like 8, right? So how do we divide 8, right? That has a perfect square, whatever. So it'd be like, we can imagine this as like square root 4 times 2, right? Over 3. And this 4, right? We can imagine him as a 2 squared. So like we can kind of take him out. I'm running out of space here, so I'm gonna move here. So like we take this 4, right? And we kind of just square him alone. So he's out of the radical as 2, because 2 times 2 is 4, right? And we leave the 2 here, inside the radical, over 3. Now, I don't think, if you don't simplify the square root of 8/3, I think you'll still get full credit, but that's just what it is in the answer key, so we don't get confused. So this is chapter 6, question 1. Complete the identity. Cosecant of x times parentheses sine of x plus cosine of x, and parentheses. So when we look at the problem, right, what can we do? Sine of x plus cosine x. There's not really much to do. If there was like a squared, like it was like sine squared x plus cosine squared of x, yeah, we probably do something, right? But not this case. So what are we left with outside the parentheses? We have cosecant, right? Remember that cosecant is the reciprocal of what? Sine, right? So we can rewrite this guy as 1 over sine of x times sine of x times cosine of x. So now what, right? Now I'm going to distribute this was cosecant into like the parentheses here. So 1 over cosine, or 1 over sine times sine. So this becomes sine of x over sine of x plus what? We have 1 over sine of x times times cosine of x. So this becomes cosine of x over sine of x. Right, so now what do we notice, right? We have what? Sine over x over sine over x, right? Can we cancel them out? Of course. So this becomes 1 plus cosine of x over sine of x. Now, what does this look familiar to? Cosine over sine, right? That looks like cotangent. So we're going to change him into cotangent. So this becomes 1 plus cotangent of x. And that should be our answer, which is letter A. Okay, so number 2, what do we have? We have sine of x over cosine of x plus cosine of x or cosine of x over sine of x. Now, I know what you're thinking, right? We have a sine x over here and we have a sine x over here, right? Can we just cancel out these two? Unfortunately, no, right? Because what do we have? We have a plus, right? And they are in their own respective like fractions. But in order to get to like that sort of problem, right, we can like combine these two fractions to one big one, right? So how do we do that? Basically, we want to get a denominator that's like common between these two. So what do? We can like multiply this denominator to the top and bottom of this one. And same for this one. We take this denominator and multiply it to the top and bottom of this one. So that's what I'm going to do. So we have sine of x over cosine of x, right? So I'm going to multiply this denominator of this fraction to the top and bottom here. So I'm going to do times sine of x over sine of x. Let me change that actually. This is looks like that. So if we multiply across, right, what do we get? We got sine squared of x over cosine of x sine of x. So I'm gonna do the same thing to this one, right? So I'm gonna write this out as cosine of x over sine of x multiplied by the denominator of this guy. So this is, what is it, cosecant of x on top and bottom. So if we multiply across, right, what do we get? We got cosine times cosine, which gives us cosine squared of x, all over, again, cosine of x sine of x. So now I'm going to combine these two into one fraction, right? So on the top we have sine squared of x plus cosine of x all over cosine of x sine of x. Cool. So now what, right? So what does that look like similar to? Sine squared x plus cosine squared of x, right? If we remember our trig identities, the most important one we have is sine squared of x plus cosine squared of x equal to 1, right? Does that look familiar? Right? So now I can write this as 1 over cosine of x sine of x. So I end up with 1 over cosine of x times sine of x. So we kind of have like a reciprocal going on here, right? So I'm going to basically like kind of plug it in. So 1 over cosine is what? Secant, right? So we have secant of x for this guy, right? And then 1 over sine is what? Cosecant, right? So we have cosecant of x like that. And that should be our answer choice of D. So our answer is D. So number 6, we have verify. So parentheses sine x plus cosine x plus parentheses squared over 1 plus 2 sine x cosine x. So, equal to 1, sorry. So how do we start this off, right? So I want to start off with the first one because there's not really much we can do here, or the numerator, sorry. Because there's not much we can do at the bottom here. So I'm going to write this out, right? So sine of x plus cosine of x, the whole thing squared, right? So I can rewrite this as essentially becomes sine x plus cosine x sine x plus cosine of x. Cool. So here, right, this looks like a FOIL problem, right? Good. So basically, I'm going to draw the arrows here for the FOIL. So first, and then, what is it, outer? Right, like that, and then like that, right? So first we have what? Sine squared times sine squared. So this gives us sine squared of x, right? And then our outer, sine squared plus cosine, so this becomes sine x, cosine of x, right? And then our inner, so cosine x and sine x, again, becomes sine x, cosine x, right? And then our last one is cosine times cosine. So we have cosine squared of x. So I'm going to combine these two because they are the same thing. So this becomes sine squared x plus 2 sine x cosine x plus cosine squared of x. Cool. So kind of similar to like the last problem, right? We have a cosine squared plus a sine squared. If I were to like switch these two around, it's the same thing, right? So I'm going to go ahead and simplify him to 1. So this becomes, or let me write up the identity actually. So our identity is sine squared of x plus cosine squared of x equal to 1. So we have sine squared of x and cosine squared of x here. So make it equal to 1. This becomes 1 plus 2 sine x cosine of x. And then remember, right, this whole thing was just the numerator on the top here. We still have our denominator here. So I'm going to write him over the denominator. So we have what, 1 plus 2 sine of x cosine of x. And would you look at that, right? We have the same thing on top and the same thing on the bottom. So I'm going to go ahead and just cross them out, right? And remember, when we cross things out, we're left with 1, like 1 on the top and the bottom, right? So this becomes 1 over 1, or just 1. And again, right, what's our answer here? It was verify this whole thing equal to 1. And what did we end up with? 1. So this is question 7. So it reads, verify sine squared of x plus tan squared of x plus cosine squared of x equals to secant squared of x. So where do we start, right? Doesn't it look a little familiar that, we have a sine squared of x plus a cosine squared of x? So for ease, right, I'm just going to move these two around so that we have a sine squared of x plus cosine squared of x plus tan squared of x equal to secant squared of x. So here I just kind of swap the places between this tan squared of x and cosine squared of x, right? And again, right, we have the same trig identity here, right? So I'm gonna write it over on the side here. Sine squared of x plus cosine squared of x is equal to 1. Bam. Sine squared of x, cosine squared of x, add a plus. So this simplifies to 1. So 1 plus tan squared of x equals to secant squared of x. Good. So now what, right? Now I'm going to go ahead and move this tan squared over here. So this becomes 1 equals secant squared of x minus tan squared of x. So a little trick, right? So there's actually three trig identities in total. So this is the most important one, I think everyone should remember, right? So it's sine squared of x plus cosine squared of x equals 1. So now, if I divide each term, right, by, like, let's say, sine of x. So sine squared of x over sine squared of x over sine squared of x. So these two cancel out, right? So sine squared over sine squared becomes 1, right? And remember what cosine over sine is? Cotangent, right? So this becomes cotangent squared of x, right? And then what's 1 over sine of x, right? Cosecant. So this is cosecant squared of x. So unfortunately, this isn't the right one for this one, but again, if we divide, so remember how we just divided everything here by sine squared of x? We can also do the opposite, right? We can also divide everything by cosine. So I'm gonna write out it again. So cosine of x plus cosine of x equal to 1, right? So I'm gonna go ahead and divide everything here by cosine of x. So sine over cosine is what? Tangent, right? So this becomes tangent squared of x. And we have cosine of x, cosine squared of x over cosine squared of x. So these just cancel out and leave us as 1. So plus 1 equals what? 1 over cosine is what? Secant. So this becomes secant squared of x. So again, notice, right, we have what? We have a secant squared x minus tangent squared of x, right? Does that look a little familiar here? So if we just move this tan squared of x over here, right, we're left with 1 equals secant squared of x minus tan squared of x. And when would you look at that, right? This guy looks a little familiar. So we're going to change him also into a 1. So this becomes 1 equals 1. So number 11, find the exact value of cosine of 50 degrees times cosine of 5 degrees plus sine of 50 degrees times sine of 5 degrees. I know, it's an absolute mouthful, right? But if we look at it, right, if we remember the like the cosine, like adding angles and like the subtracting angles and all that stuff, this is just a formula, right? So this looks like this is like so it's cosine alpha plus like beta, or maybe so it's like plus or minus, right? So this would be like cosine of alpha, cosine of beta, and then remember cosine, right? It's like it's kind of flipped, right? So I'd say it's like cosine of adding these two angles. It's cosine this minus, right? So here, so I did plus or minus down here or over here, right? But here it's minus or plus, or this would become sine. Sorry, sine of alpha, sine of beta. So looks a little similar to this, right? So we have cosine of alpha, right? Cosine of beta, and sine of alpha, sine of beta, right? So if we were to combine this all together, right, this looks like cosine of 50 degrees minus 5 degrees, sorry. So if we were to do this literally, right, this would just be cosine of 45 degrees. And if we look at the unit circle, right, it's quadrant 1. This would be 45 degrees. So cosine is just a value of 2 over 2. All right, so question 13. So the whole word thing is, right, it's giving us that sine A is equal to 4 over 5, right? And A is in quadrant 1. And then it's giving us another triangle, right? That cosine B, or cosine beta, is in 5, cosine of beta is equal to 5 over 13. And that B is in quadrant 4, right? So if I were to like draw the first triangle, right, so I'm doing alpha, right? So quadrant 1. So the triangle looks something like this. So this is A, right? So we have 4 over 5. So remember sine is, it's opposite over hypotenuse, right? So this is 4 over 5, right? And then our second triangle is in what? Quadrant 4. So it's going to look like this. Oh, what the? That's, there we go. Yeah. So this is beta. And we're given what? Cosine is equal to 5 over 13. Okay, cool. And then it's asking us that, what is sine of alpha plus beta? So again, right, another formula. So the formula in this case of sine alpha plus beta is equal to sine of A cosine of beta plus sine of beta times the cosine of alpha. So let's fill it in as we go, right? So we have sine of alpha already. They gave us, it's 4 over 5. So 4 over 5, right? the cosine of beta is what? 5 over 13. So 5 over 13 plus the sine of beta. So we don't have this yet, right? So we need to find this opposite side. How do we do that? Pythagorean theorem, right? So we have a squared plus b squared equal to c squared. So let's start with 5 here, right? So 5 squared plus b squared is equal to 13 squared. 13 squared. So this becomes 25 plus b squared equals 169. I'm going to go ahead and isolate the b squared, so I'm going to subtract the 25 from both sides. It becomes b squared equals 144. So if I square both sides here, right, I'm going to get b is equal to plus or minus 12. But now, here's the most important part, right? Where is this triangle located? In quadrant 4, right? And what do we know about quadrant 4? Like, what's the cosines and sines, right? So cosine in quadrant 4 is positive, but sine is negative. And so what do we have here? We have b is equal to plus or minus 12, right? But we know that the sine value here is, or the y value is negative. So this has to be negative. So this becomes b is equal to negative 12. Just like that. Cool. And then what about triangle A, right? We need to find the cosine. Or I guess we can fill this in first, right? So sine of beta is what? Negative 12 over 13. And we need to find cosine of A. So we have what? We're missing one side, and we have our opposite and our hypotenuse. So again, I want to do the whole Pythagorean theorem again, right? So I'm going to do it here. So a squared plus b squared equal to c squared. So I'm missing a, so I'm going to do a squared plus 4. 4 squared equals to 5. 5 squared. So this becomes a squared plus 16 equals 25. So a squared is equal to 25 minus 16. So I think that's, what, 9, right? Again, so I'm going to square this. This becomes a equals plus or minus 3. Again, right, what quadrant is triangle alpha in? Quadrant 1, right? What do we know about quadrant 1? We have, what's the cosines and sines here? We have positive and positive, right? So that means that this side has to be positive. So this becomes a equals 3, like positive 3. So just like that. So our cosine of a becomes 3 over 5. And now we just multiply across. So we have what? 4 over 5 times 5 over 13, right? This becomes 20 over, what is that, 65, right? And then plus, and I see a negative here, so I'm going to do a parentheses here. So 12 times 3 is what? 36, right? So negative 36 over 13 times 5, 65. So we have 20 over 65 plus negative 36 over 65. So we can also rewrite this as like that. So 20 minus 36 is what? Negative 16, right? So we have negative 16 over 65. And that's our answer for A. So in our second part, we have part B, cosine of alpha plus beta. So from the last question, we know that the cosine formula of this is like that, right? So this becomes cosine of A, cosine of beta, and then we have a plus here, right? So this becomes minus. Minus sine A, sine beta. So cosine of A, right? We have what? 3 over 5. So 3 over 5. Cosine of beta is what? We have 5 over 13. 5 over 13 minus sine of alpha. So 4 over 5. 4 over 5. And sine of beta. So we have negative 12 over 13. Negative 12 over 13. Again, multiply across, right? So we have 3 over 5 times 5 over 13. This becomes 15 over 65. And this, so I see negative here, so I'm going to do parentheses. So 4 times 12 is what? 48. So negative 48 over 65. So we see what? We have a negative minus a negative, right? Or minus, yeah. So this becomes what? 48 plus 15. Let's do that real quick. 15, so 8 plus 5 is 13. This becomes 63. So this becomes 63 over 65. Okay, and so our first question here is question 5b. Okay, and so our question here is, this is question B. Oh my God, okay. And so this question is question 5, part B. So it reads, y equals 2 sine of 4x minus pi, close parentheses. So what I like to do when I first start these questions, right, is to write like our basic function, right? So we know that's what, it's y equals sine of x, right? So I would write like the model question, right, that has the a's and the b's and the c's. This would be like y equals a sine of bx minus c plus d. So, right, so now I want to figure out, kind of like fill in the gaps, right? So what do we not know? We don't know the a's, the b's, and the c's, right, and the d. So I'm just going to label out these like as I go, right? So I think here it's asking, what is the amplitude? So the amplitude is the same thing as the a, right? So I'm going to look at this equation. So I have y equals 2 of sine, right? Or 2 sine, sorry. So our a here is going to be 2, right? And then the next question is, what will be the period? So what is period again? So period is our b, right? So again, so we have y equals 2 sine of 4x. So here our b is just, right here. So our b is just 4, right? We're not quite done yet though. So we know that period has a formula where it's 2 pi over b, right? So here our b is 4. So I'm just going to go ahead and plug that in. So it's 2 pi over 4. So these kind of like, not cancel out, but like they kind of go into each other. So, or simplify it, my bad, there we go. This becomes pi over 2 because we just divide both by 2, right? So this becomes 1 and this is 2. So just pi over 2. So our period is just 2 pi, or pi over 2. Ah, damn, okay. The next question is, what is the phase shift? Our phase shift is our c, right? So what do we have here? We have a 4x minus pi, right? And we have bx minus c here. So I plug in this minus pi into here, right? Into the c. I'll get like a actually I guess like this is easier. Like c here is just pi, if that makes sense. Like we have a negative pi here and we have a negative c here, right? So if I were to plug in a pi, right, into the c, I would just get bx minus pi, right? And that's how we get here. I like to think of it like we just do kind of the opposite of whatever's here. So let's say in this case, right, we had like a plus pi here instead, right? My c here would be negative pi because it's like the opposite of like whatever is inside the parentheses. But so in this case, we have a negative pi, so our c here is just pi. But our phase shift isn't quite done yet because we know that phase shift is equal to c over b, right? So what's our c here? We just found that it's pi, right? So this becomes pi over b, right? And we found that b was 4, so this becomes pi over 4. Phase shift is pi over 4. Next question is, what is the basic function? Okay, we found this earlier, right? That our basic function is just what? Y equals sine of x. Because I just kind of find, like, in these sort of like sine, cosine, tan questions, I find that a basic function is really easy because we just look at it, right? And we just look for the word, right? So in this case, we have y of sine, and that's our basic function. Also, don't forget the y equals sine of x. So what are the basic, what are the key points of the basic function, right? So let me draw like the basic graph. So this is a y equals sine of x graph, right? So these will always look like this. So our basic function looks something along the lines of this, where we have 5 points. We have 1, 2, 3, 4, and 5 points, right? So what are the key points of the basic function? So if we were to go around like the unit circle, this is how we get the basic function. So like imagine unit circle, right? So we always start at the angle 0, right? But what point do we start at here? It's 1, 0, right? So at the angle 0, right, our y or our sine is 0. So like our first point here is 0, 0. So this let me think, this is key points. So our first coordinate is 0, 0, right? And then if we travel up to the 90-degree point, right? This is pi over 2, right? So pi over 2. And then what coordinate lies here? We have what? 0, comma 1, right? And what's our y here? 1, right? So it becomes pi over 2 is like the angle, and then our y value here. So like that. And then we travel over here to pi, right? This is pi. What coordinate do we have here? We have -1, comma 0, right? So again, we have our angle is pi. So this becomes pi, comma, what's our y coordinate? 0, right? 0. And then if we travel down to here at 270, we have what? 3 pi over 2. And what coordinate is here? 0, comma, -1, right? So again, we have 3 pi over 2, and our y value is -1. 3 pi over 2, -1. And then we travel back to 2 pi, right? Or 0. So this is also 2 pi, right? Our coordinate was what? It was 2 pi, and our y value is what? 0, right? So this is 2 pi, comma 0. Little bit of a mishap here. So I'm going to restart. Okay, so our final key points, right? So it's basically, I'm taking these key points from the basic function, right? So this is y equals sine of x, these are the key points. I'm going to plug each one basically into this equation, right? So we know that our first point is always going to be what? The phase shift, right? And what did we find the phase shift was here? Pi over 4, right? So our first point is pi over 4, comma what? So we have our y value here is 0, right? So I want to take the amplitude that we found here in our original equation, right? So it's a equals 2. So this 2, right? I have to multiply it to each y value essentially. So here it's our y value is 0, right? So 0 times 2 is what? 0, right? So our first coordinate here is pi over 4, comma 0. Second set of coordinate, right? So I did it here already, but so basically to find our next intervals, right? We have to divide the period over 4. So we found that our period here was what? Pi over 2, right? So pi over 2 divided by 4. This 4 means we have 4 other points to find, kind of. So here, right? When we have a fraction divided by a whole number, I like to just kind of draw an arrow and multiply this number by to the denominator. So in this case, it becomes what? Pi over 8, right? So now I kind of want to take our first point here and add pi over 8 to it. So here, right, we have pi over 4. So pi over 4, right, plus pi over 8. But now we notice that these don't match up, right? The denominators do not match up. So I'm going to do something to this side to make it something over 8, right? So I'm going to multiply it times 2 on the top and bottom. So this becomes 2 pi over 8 plus pi over 8. So now our next coordinate, right, is 3 pi over 8, comma what? We look up here, and what's our y value here? 1, right? Again, so I'm going to multiply the amplitude to that 1. So now I get 2. So like that. The next coordinate is we take our prior x value, right? So in this case, we just found 3 pi over 8, right? And we're going to add pi over 8 again, from this, the period before, right? This is our interval kind of thing. So I'm going to add 3 pi over 8 plus pi over 8. So 3 pi over 8 plus pi over 8. This gives me what? 4 pi over 8. 4 pi over 8. And we found our y value up here is what? 0, right? So 0 times 2 is what? 0. Just like that. And then our next coordinate here is, it's going to be 4 pi over 8. 4 pi over 8 plus pi over 8. So now what do I get? I get 5 pi over 8. So 5 pi over 8, comma what? We found here it's -1, right? So -1 times 2 is -2. And then our last coordinate, right? Same thing, 5 pi over 8 plus pi over 8. So 5 plus pi, or I guess 5 plus 1. So it'd be 6 pi. 6 pi over 8, comma what? We found here it's 0. So 0 times 2, 0. And so these are our key points, our final key points. So let me go ahead and mark that off. Oops. Okay, so here I want to like draw like a regular like coordinate grid, right? Like how we usually do when we graph, right? So just like that, right? So now I kind of want to look at our points, right? What do these fall into? So I start with pi over 4, and then I end off with 6 pi over 8. So since the numerator here is smaller than the denominator, right? I know that this is like within parameters of pi. So I'm going to put my endpoint here as pi, right? This is negative pi. And I'm going to look at our y value. So we have what? 0 and 2, right? So I'm just going to mark up like somewhere in the middle here just as 2. And this is negative 2. And so now we have, look at our denominator, right? We have what? 8, right? So that means I want to have 8 intervals in between 0 and pi here. So 1, 2, 3, 4, 5, 6, 7, and then this is our 8. So we have 8 intervals, right, between 0 and pi. So each mark is like a pi over 8 kind of thing. So our first point here is pi over 4, right? So we know that pi over 4 is what? Just equal to 2 pi over 8, right? So to our second mark here, and then comma 0. So this is our first coordinate. 3 pi over 8, comma 2. So now I want to count. 1, 2, 3, right? And then we have our 2 mark up here. So 3 pi over 8, 2. Next coordinate is what? 4 pi over 8, comma 0. So 1, 2, 3, 4, comma 0. And then 5 pi over 8, comma negative 2. So 1, 2, 3, 4, 5, negative 2. Oops. It'd be like, what, here? Yep, something like that. And then our last coordinate is what? 6 pi over 8, comma 0, right? So 1, 2, 3, 4, 5, 6, comma 0. And so now we just kind of want to like connect the dots, right? So something like that. Ooh, that's pretty bad. Hold up. Again, that's pretty bad. What in the world? Let's try that one more time. Yeah, there we go. Something like that, right? And so this is what our final graph should look like. And let me double check. Oh, sorry. Graph one cycle the basic with dashed lines. Okay. So this is 0. Our first key point of our basic function is what? 0, 0, right? So 0, 0. And we go to pi over 2, comma 1. So this is intervals of pi over 8, right? So we know that, like, what's half of pi over 8? It would be 4 pi over 8, right? So 1, 2, 3, 4. So our first coordinate here would be like somewhere around here, I guess, right? And the next coordinate is pi, comma 0. So pi, comma 0. So unfortunately, I didn't draw the rest of the 2 pi, like period here, but it looks something along the lines of this. And then we go on. But yeah, I believe in your actual exam, like I don't know if like they give you like a drawn out like grid like this already, but you need to draw like one whole cycle. So this would continue on to like 2 pi. So like it would go down like looking like this. Okay, and so in this question, right, in the previous question we did 5b, right? So like there's like a sine graph. So I wanted to cover our bases here and do like a cosine graph, right? So this is question 5e. It reads y equals 4 cosine of parentheses half x plus pi over 4. So again, right, I want to like write out our model. Our model formula is what? Y equals a, and this time it's cosine of bx minus c plus d. Okay, cool. So again, right, I want to fill in the blanks and answer a, b, and c, right? So if you look here, right, what's our a? We have what? A 4 here, right? So this becomes a equals 4, right? So what's our b now? It'd be like a bx, right? So bx, and what do we have here? We have a half. So our b is half. But the question is asking here, what will be the period? So again, right, we know that a period is equal to what? 2 pi over b, right? So in this case, it's what? 2 pi over 1/2. So now what, right? So now I kind of want to just do that, right? So I multiply like this denominator, or I guess if you write it out like completely, right? It would be like 2 pi over 1 times the reciprocal of 1/2. So this becomes like that. And then we just multiply across. This becomes 4 pi over 1. So our period here is equal to 4 pi. Okay, it's cool. So now what's our phase shift, right? So if we look here, what's our C? We have a pi over 4, right? If you plug that into here, this would give us a negative pi over 4. So just like that, right? And in the other case, right, let's say like instead of a plus pi over 4, it would be a negative pi over 4, right? So minus pi over 4, if you plug that into here, we get bx plus pi over 4. So basically kind of whatever is in here is that we do the opposite. Like C is equal to the opposite of this. So our C here is negative pi over 4. So our phase shift, right? We know that the formula for phase shift is what? C over B, right? So C over B. So we found that C was negative pi over 4. So negative pi over 4. And what was our B again? It was 1/2. So here we have a fraction over a fraction, right? So here I like to draw arrows, right? So I'm going to take the top number of the bottom fraction, right? And draw like that. And then the bottom number of the bottom fraction goes to the top of that. And now with these arrows we multiply, right? So at the top I have what? This becomes negative 2 pi over what? Over 4. And we have a 2 and a 4 here. So I want to cancel out this 2, right? This becomes 1 and this becomes 2. So now I'm left with negative pi over 2. So our phase shift here is negative pi over 2. Now, do we have a d here? If we look at the original formula, do we have a d? Do we have a number outside of here? No, right? So we just leave that alone. Okay, so now it's asking what is the basic function? So my basic function is cosine. Because if we look at the original formula, right? What's the only word here? Is the way I like to think about it, right? So y equals what? Cosine. So cosine of x. And so now, the basic like trend of this guy would be like something along the lines of that. So we have first point here, second point here, third point here, fourth point, and then fifth point. Again, I guess I'll draw the unit circle again. So unit circle, right? So our first angle and our first point, right, is what? We start at 0, right? And our first point here is what? 1, 0. So our angle is 0, right? So let me write out key points here. Key points, right? So our angle was 0. And our first x coordinate is what? 1, right? So 1, 0 is our first point. If we go up to pi over 2, what's our coordinate here? We have what? 0, 1, right? So pi over 2, and what's our x coordinate? 0. So if we travel over to here to pi, right? What's the coordinate here? Negative 1, 0, right? So this becomes what? What's our angle? Pi, and then what's our x coordinate? Negative 1. Again. So now we travel down to 3 pi over 2, and what's our coordinate here? We have 0, negative 1, right? So angle is 3 pi over 2, and our x coordinate is 0. And what's our final coordinate, right? We go back like full circle to 2 pi now. And what's our x coordinate? It is 1. So 2 pi and 1. So these are the key points for y equals cosine of x, right? So now it's asking what will be the final key points. So now this is final key points. So again, right, what do we know about final key points? What's our first point again? It's our phase shift, right? So our phase shift here is negative pi over 2. So our phase shift takes place of our x coordinate here. And I want to look up here, right? What's our base function? Y? It's 1, right? So 1, I want to plug that into the amplitude here. So I have what? Amplitude is 4, right? So 1 times 4 is 4. So I have like that. So our first coordinate is negative pi over 2, 4. Again, oh, right, and I forgot yet again. So there's a formula, I don't know what it's called. It's period over 4, right? So our period here is what? 4 pi. So 4 pi over 4. And we have a 4 on top and 4 on bottom, right? So this becomes 1, this becomes 1. So we're left here with pi. So here, what does that tell us, right? This thing, like period over 4 basically means we're trying to find the next 4 intervals of the period that fit inside of it, right? So here, our first coordinate was what? Negative pi over 2, right? So now I want to add pi to that. So negative pi over 2 plus pi, like that, right? So I'm going to get this pi in terms of like the over 2, right? So this becomes negative pi over 2 plus what? So I'm going to multiply 2 on top and bottom of this pi. So this becomes 2 pi over 2. So negative pi plus 2, right, equals what? Pi over 2, right? So our next coordinate here is pi over 2 comma what? What do we have here? What's our y? 0, right? So 0 times our amplitude of 4 gives us what? 0. So something like that. And then again, we do pi over 2 plus, and we found that pi is equal to 2 pi over 2, right? So 2 pi over 2, so this becomes 3 pi over 2. 3 pi over 2 comma what? What's our y value here? Negative 1, right? So negative 1 times 4 is negative 4. Again, 3 pi over 2 plus 2 pi over 2 gives us what? 5 pi over 2, right? 5 pi over 2, and we look up here, what's our y coordinate? 0. So 0 times 4, 0. And then let's put our final coordinate here. So we have 5 pi over 2 plus 2 pi over 2 again. So this gives us what? 7 pi over 2. 7 pi over 2 comma 0. Oh, actually, no, not comma 0, sorry. We look up here, what's our y value? 1, right? So 1 times 4 is 4. And so this completes our final key points. So to graph this, right, I kind of just want to make a regular coordinate grid, right? And so I'm going to look at our points here. Actually, they want us to do, actually no, yeah, this is better. Okay, so what's my beginning point? Negative pi over 2, right? And then my end point is 7 pi over 2. So I know that this is going to be a period of 4 pi in both sides, right? So I'm going to draw 4 pi here. This is negative pi, or negative 4 pi. Negative 4 pi, right? I'm going to look at the amplitude. What do we have? We have 4, right? And negative 4. So I'm going to draw negative 4 down here, and I'm going to draw 4 here. Something like that, right? So I'm going to go ahead and divide this into increments that fit our thing, right? So I'm going to draw like 2 pi here, 2 pi. This would be like pi. This is pi over 2, 3 pi over 2, like that, right? And then this is 3 pi. So we have pi, 2 pi, 3 pi, 4 pi. So same thing on this side. So this middle is negative 2 pi. Middle of this is negative pi. And middle of this is negative 3 pi. And then I'm going to add an increment in the middle of each. So now I have our pi over 2 increments. So our first point is what? Negative pi over 2 comma 4, right? So our first increment here, negative pi over 2, and then 4. Something like that. What's our next set of coordinates? We have pi over 2 comma 0. So pi over 2 comma 0. Next coordinate is 3 pi over 2 comma negative 4. So 1, 2, 3, right? And then negative 4 down here. So something like that. Our next set of coordinates is 5 pi. 1, 2, 3, 4, 5, comma 0. And then our last set of coordinates is 7 pi over 2. So 1, 2, 3, 4, 5, 6, 7. Oh, I've got to draw this. There we go. And then this should be pi, or 4, sorry. So, yeah, that's about right. So now I just kind of want to connect the dots, right? So starting up here, down here, like that, and like that. And, oh, right, it asks us to draw the basic function with dashed lines, right? So we know this is our key points here. So I'm gonna go ahead and put that in, right? So 0, comma 1, so something like run here. Pi over 2, comma 0, so here. Pi and negative 1, so something like that. 3 pi over 2, comma 0, somewhere around here. And then 2 pi, 1. So dashed lines here. And so this is our complete graph calculations and final points of question 5e. So here they give us a figure, right? It's a triangle with theta here, and our adjacent here is 5, and our opposite is 2. So they're asking us to find what? Oh, I've got to write it out. Oops. So here it's the sine of 2 theta. And then our b is cosine of 2 theta. Okay, so they're asking us to find sine of 2 theta, right? So what does it look familiar to? The 2 theta looks familiar to our double angle formula, right? So I did kind of cheat a little bit. I did write out the formula on the side here. So if we look here, right, sine 2 theta is equal to what? 2 sine theta and cosine theta, right? So this becomes 2 sine of theta cosine theta. So now we need to fill in the values, right? But we're not quite, like, we can't start here yet because we need to finish this triangle, right? So we need to find our hypotenuse. So how do we find that? So they gave us on the figure that it's a right angle, right? So we know that we can do our Pythagorean theorem, right? So a squared plus b squared equals c squared. So let's take a, this is a here in this case. So a is 5 squared plus 2 squared equals c squared. So we square this, 25 plus 4 equals c squared. So this becomes 29 equals c squared. And then we do this and we square root both sides. This becomes,
oh, sorry.
you're good. No, it's all good, it's all good. So the c becomes, c equals plus or minus 29, right? So they don't give us a quadrant where this lies, right? But we know that our hypotenuse is always what? Positive, right? So this becomes c equals square root of 29. So square root of 29. Okay, so now that we know that it's this, right? Now we're just gonna plug this in. It becomes 2 sine, right? The sine of this is what? 2 over, it's opposite of hypotenuse, right? So this becomes 2 over square root 29, right? Times what? Cosine. This becomes 5 over square root of 29. And so now I kind of just want to like multiply across here. So this becomes 2 of 10, and then we multiply 2 radicals of the same thing, right? They kind of like combine, and we get rid of the square root. So this becomes 10 over 29, and then we multiply this to the top. So this becomes 20 over 29. And so that's answers part B. So now, what about cosine 2 theta, right? Here, if I look at the formula, right, I have, actually cosine has like 3 different formulas, but I would advise using this one because it's like the simplest one. So this is cosine squared theta minus sine squared theta. So go ahead and plug this in, right? So this is cosine of square root of what? We have 5 over square root 29 minus sine squared of what? We have 2 over square root 29, right? And so now I kind of want to get rid of this because we kind of answered that already. So now this whole thing becomes squared now. So like, it'd be like this. So now, when we square like a fraction, right, we have to square the top and the bottom. So 5 squared becomes what? 25, right? And this 29 squared becomes just 29. Minus what? We have 2 squared, so 4, over square root 29. So this becomes 29. So just combine these two, right? So it becomes 25 minus 4. This is 21 over 29. Okay, so this is question 1 of chapter 7. So it gives us a figure, right, or like just numbers, right, of A equals 42 degrees, C equals 96 degrees, and little c is equal to 12. So I'm just going to draw something like this, right? These aren't really the scale, but I'm just going to do A, B, and C, right? So this is 42 degrees, and C is 96 degrees, and little c is equal to 12. So over here, this is little c. So this is now A, this is B, and so we're trying to find, it says, what is it? Solve the triangle, right? So we're trying to find all of the sides and all the angles here. So, okay, so the simplest thing we can do here is find angle B, right? So angle B is equal to 180 minus, we have 42, and we have 96. Oh boy, okay, what is that? So let's do, you're all good. Oh, like, I'm just recording, like, I don't have a class here.
Okay, you can.
Yeah, okay.
I was right side. Thank you.
So this is 96 plus 42. So this becomes what, 8? This becomes 138. So 180 minus 138, this becomes 2, 7, 4, so 42. Angle B is 42. 42 degrees. So write that out. Angle B is equal to 42 degrees. Okay, cool. So now what? Now we can use law of sines, right? Because now we know all the angles, and we know like one side, right? So let's start off with angle A, because that's what they gave us, right? So let's set up the thing, right? So it's sine of 96 over little c, so 12, equal to, now we do angle A, right? So sine of what? We have angle 42 degrees, the degrees here. So 42 degrees over A. Now, this becomes, we kind of cross multiply here. So A sine of 96 degrees equal to 12 of sine of 42 degrees. And then if we were to move this guy over, or isolate the A, right, we get 12 sine 42 degrees over sine of 96 degrees. And so this is our side A. So now we need to find side B now. So same thing, right? I'm going to use side C because we have a relation already. So this becomes sine of 96 degrees over, what's that, 12? 12 equal to what? We found the angle B was what? 42, right? So this becomes sine of 42 degrees. Wait a minute. Oh, this was 96. I'm so sorry. So change that. Wait, what in the world? Oh, no. My bad. They have the same angle. Sorry. Okay, so sine 42 over B. So cross multiply again. This becomes B sine 96 degrees equal to what? 12 sine of 42 degrees. So if I were to isolate this again, this would be B equals 12 sine 42 degrees over sine of 96 degrees. And so, yeah, now we found angle A, or side A, and side B. All right, guys, unfortunately, I am a little bit out of time here, so this is going to be my last question. I wish you guys nothing but the best of luck on this exam. And, yeah, that's about it. See ya.